Hi everybody, this video is going to talk about absolute value equations. So we're going to start off with two simple examples here. I want you to think, if we have the absolute value of x equal to 5, what are some possible values of x? Okay, we know that the absolute value takes whatever's inside, okay, and turns it positive. It's basically just finding the distance between that number and 0. So if I take the absolute value of positive 5, I'm going to get positive 5. But if I take the absolute value of negative 5, I also get positive 5. So there are two values that make this equation true. Okay. For the second one here, though, is there any number that we can take the absolute value of and get a negative number? Okay. The answer is no. There are no possible values of x that would make this true. So if you ever see an absolute value equal to a negative number, you know it's impossible. Okay, so that's going to come up later. Just be on the lookout for that. So let's look at some actual solving. So here's some steps that you can follow. Basically, we just want to get the absolute value expression by itself. We're going to create two cases because we know that it could be equal to the positive or the negative of whatever's inside the absolute value. And then we're going to solve each one and make sure that they actually work. Okay, so let's take a look here at our first example, and we said that we have to get the absolute value expression by itself. The absolute value expression is the absolute value bars and everything inside of it, not the plus 17. It's on the same side as the absolute value expression, but it's not actually part of that expression. So we need to subtract 17 from both sides first before we can continue. So we have the absolute value of y minus 1, and then if we subtract 17 from both sides, that's going to be equal to 6. So now we need to set up two cases. Okay, the first case is that what's inside of our absolute value bars could be equal to positive 6. But we also know that it could be equal to a negative 6 as well. So we need to check both of these cases. So we have two simple equations to solve. Okay, our first one gives us y equals 7, and our second one gives us y equals negative 5. Now, what we need to do is we need to plug those back into our original equation and make sure that they actually work. So our original equation is the one that we started with at the very beginning. Let's check the first one here, y equals 7. So if I plug in 7 for y, is it going to make both sides equal to 23? Well, we'd get the absolute value of 6 plus 17, which is going to make this true. Okay, so we know that y equals 7 actually works. Okay, so let's test negative 5 here. Let's plug it in. And again, we're checking to make sure that both sides actually equal 23 when we plug it in. So we get the absolute value of negative 6, which we know is a positive 6. And if we add that to 17, we're going to get 23. So this works as well. So there are two solutions, okay? Y could equal positive 7, or it could equal negative 5. Either one of those values is going to make this equation true. So let's look at another example here. Now, again, we need to start by isolating our absolute value expression, okay? That includes the absolute value bars and everything inside of it, but it's not going to include that 16. So it's multiplying the absolute value expression. Let's just divide by 16 to get rid of it. So now we have r minus 5 in our absolute value bars still equal to negative 2. So now we can take what's inside of our absolute value, which is the r minus 5, and we can set it equal to a negative 2 and a positive 2. So establishing those two cases. Okay, when we solve, we get r equals 3 and r equals 7. So let's plug them back in and see if they work. Okay, so let's see. We have 16 times 3 minus 5 or I should say the absolute value of 3 minus 5. Okay, so the absolute value of 3 minus 5, which is negative 2. Okay, but there's a problem here because that negative 2, when we take the absolute value, becomes positive. And positive 32 does not equal negative 32. So we have an issue. R equals 3 isn't actually a solution. It doesn't work. So we're going to cross it out. Hopefully our second one does. Okay, so again, let's plug it in. 16 times the absolute value of 7 minus 5. Okay, so we get 16 times the absolute value of 2, but we get that same issue. We get positive 32, which does not equal negative 32. So 7 doesn't work either. So either we messed up really bad, or there was something at the very beginning that we should have noticed that told us that this equation wasn't going to have a solution. Okay. Now that thing that I'm hinting at, let me change my pen color here, is right here. Okay. So I want you to think, what could we have noticed right here that told us that there wasn't going to be a solution to the equation? Well, at the very beginning, we talked about how an absolute value can never be equal to a negative number, and that's exactly what we have here. There's no possible value of R such that I could make the absolute value of it equal to negative 2. It's just not possible. So this actually has no solution. All right, guys, that is it for this video. Please let me know if you have any questions, and have a great day.